All right, triangles. There's one rule you need to know about triangles. Any side has to be less than the sum of the other two sides.
Okay.
Okay. Notice that if I have a triangle like this, this bottom side, x, necessarily has to be less than y plus z. Can you see why?
Yeah.
Okay. And the converse of that, in other words, this is the part you need to memorize, but there's a second part that any side has to be greater than what? What's the second part of this?
Wait, so any side has to be greater?
It has to be less than the sum of the other two sides, and it has to be greater than what?
Greater than the
difference.
The difference.
Of the other two sides. In other words, you cannot have a triangle with those dimensions. Why? Because 2 is not greater than 9 minus 7. It's equal, but that doesn't, it's got to be greater.
Okay.
Okay? It's less than the sum, but notice that 9 is not less than the sum of the other two sides.
Yeah.
So this cannot be a triangle. If any triangle that you draw has to satisfy these two conditions, and the only one you really need to memorize is that, because you can kind of figure out the other half of it, right?
Yeah.
That's the secret to memorizing stuff in math, is memorize as little as possible.
Okay.
When I memorize this rule, that's the only thing I memorize, because I know the other half is the opposite sign, greater than. It's the opposite of sum, which is difference of the same two sides. So it's not hard to memorize. You only have to memorize half of it.
Okay.
Okay? So using that principle is number one possible?
No.
Well, and you have to check all three sides. No, why?
Because 15 and 37 add to more than 53.
Actually, they don't. They add to 52.
Oh. So then, yes.
Now, hold on. Remember, we have to check all rules for all three sides. So, let's start with 15. Is 15, first of all, less than 37 plus 53?
Yeah.
Okay. Is it greater than 53 minus 37?
I don't know.
Exactly. This is 16.
Yeah.
So 15 is not greater than 16, so it fails immediately on the second test.
Yeah.
Okay. And if it would have passed both tests, then we need to test 37. Make sure it passes both tests. In other words, let's take the triangle 7, 8, 9.
Okay.
Okay? Examine that. Is that less than 8 plus 9?
Yeah.
Is it greater than 9 minus 8?
Yeah.
Okay, now let's examine 8. Is that less than 7 plus 9?
Yes.
Is it greater than 9 minus 7?
Yes.
Okay, now let's look at 9. Is that less than 7 plus 8?
Yes.
Is it greater than 8 minus 7?
No.
Sure it is. 8 minus 7 is 1.
Oh, yeah.
Okay, so this is a triangle. You can make a triangle that has those three sides.
Yeah.
8, 9. You cannot make a triangle that has these three sides
Yeah.
because it violates the rule. So you have to check both conditions for every side of the triangle until you can say that, no, you can't make a triangle out of that.
Okay.
Let's look at the second one. 9, 16, and 8. So let's go through them one at a time.
Okay.
Does 9 pass both rules?
Yes.
Does 16 pass both rules?
No.
Which rule does it fail?
The second one?
16, remember, has to be less than the sum of the other two, which is 17. So it passes that one. And it has to be greater than the difference. Well, the difference is only 1.
Oh, okay, yeah.
So it passes that one. About 8.
I think 8 passes both.
That is a triangle.
Okay.
That's what you have to do on questions like that, is you have to put every single side through both rules. Not spend a whole lot of time on number 3. Basically, what number 3 says is there's 2 points. Shortest distance between those 2 points is a straight line.
Okay.
If I try to connect those 2 points with a crooked line, the sum of x and y has to be greater than z, right?
Yeah.
Merely because it's not the shortest distance between 2 points. It's the longest distance. So x plus y has to be greater than z. And that's what our theorem says, is that any side, z, has to be less than the sum of the other. So z has to be less than x plus y. And z also has to be greater than y minus x or x minus y, depending on which one's bigger.
Okay.
Okay? All right, these word problems are all just triangle problems.
Okay.
It's as if they drew a triangle with dimensions and want you to solve for whatever's missing.
All right.
Okay, this particular triangle is 5750 and 1170. And they want to solve for x, the horizontal distance.
Yeah.
So how do I do that?
The Pythagorean Theorem.
Okay, keep going.
So 1,170 squared.
All right, I'll go that route. It's all right.
Is that harder?
Not really. No, you're starting with the Pythagorean Theorem. Go ahead.
All right, and then plus, is it 5,750 squared?
No, it's the sum of the two small sides.
All right, yeah.
In other words, the hypotenuse is always the biggest side.
Okay.
So it's the sum of the two small sides equal the square of the hypotenuse.
Yeah.
Okay? So as long as you know the Pythagorean Theorem, you can always solve these. Okay. You have a
Yeah.
calculator in front of you?
Yeah.
Okay, let's come up with some numbers. What's 1170 squared?
2,340.
I didn't hear it.
2,340.
Does that make sense?
Yeah.
That's 2 times 1170.
Oh.
We got to square it. You got to raise it to the second power.
136. Wait.
No, that sounds right.
1,368.
I'm sorry, say again?
136,008. Wait.
Okay.
I don't know if this is like 1 million.
Hold on, let's talk for a second about that. What's 1,000 times 1,000?
100,000.
It's a million. That's the relationship between 1,000, million, billion, trillion, and gazillion. Each one is 1,000 times the other.
Alright.
So 1,000 times 1,000 is a million. 1,000 times a million is a billion.
Okay.
So forth and so on. And that's a piece of knowledge that it's worth knowing.
Alright.
Okay? If 1,000 times 1,000 is a million, then where's the decimal point going to be on this number?
Right after the 1.
Okay, so what's the answer?
1,368,900.
Notice that just knowing that 1,000 squared is a million tells you whether this is 136,000 or whether it's 1,368,000.
Yeah.
Okay, plus x squared. What's this number squared?
33,062,500.
Like that?
Yeah. Yeah.
Okay. That's good. And I'm glad you said 33 million and not 3 million. Because 5 squared is 25. So 5,000 squared would be 25 million. So this is just right. Okay, now take that number and subtract that number. What do you get?
Okay,
We don't want to spend too much time on arithmetic here, but it's important to do one of them.
31,693,600.
Now what's x?
So you gotta divide that by 2?
No. Take the square root of both sides. In other words, dividing by 2 does not leave x.
Yeah.
It leaves x squared divided by 2. If I want x by itself, I got to take the square root of this side.
Okay.
I got to do that. Well, if I got to do that on the left side, I got to do that on the right side. When I do it on the left side, it leaves x, which is what I want. What's the square root of 31,693,600?
5,629.7.
We'll forget the decimal point for the moment. 5,629. Does that answer make sense?
Yeah.
It does. It's less than the hypotenuse.
Yeah.
I would have expected it to be a little bit more or less, but it doesn't violate any ballpark checks immediately.
Yeah.
In other words, if it was 5,751, I would know it was wrong.
Yeah.
Because the hypotenuse has to be the longest side. So, assuming that we didn't do any calculator errors there, that's the correct answer. Now, let's talk for a minute because I think I can help you.
Okay.
If there's one thing that you're going to have to do, what grade are you in, Julian? 9th or 10th?
10th.
There's one thing you're going to have to do tons of for the next 3 years is solve right triangles.
Yeah.
Okay? And there's really only 2 situations. When they give you a right triangle to solve, either they give you the 2 short sides and ask you to solve for the long side, or they give you the long side and one of the short sides.
Yeah.
So those are the only 2 situations you have to ever do. Well, let me give you a shortcut. Rather than having to go all the way back to the Pythagorean Theorem, let's learn how to do this directly. If I am solving for the hypotenuse, then z is always the square root of the squares, the sum of the squares of the 2 short sides, like that.
Okay.
And that's direct. That's the fastest way to solve for z. Okay? If I am solving for one of the short sides, regardless of which one it is, doesn't matter whether it's this short side or this short side.
Yeah.
It's the square root. Notice that everything starts with square root of.
Yeah.
Okay? Only in this case, it starts with the hypotenuse squared minus the other side squared.
Okay.
Okay? If you can memorize both of these things, it will make solving right triangles much, much quicker for you.
Okay.
Now, when you take the ACT test or the SAT test, there's going to be at least 6 problems on there where you have to solve right triangles, where they give you 2 sides and you have to come up with the third. Well, it's going to be a shame if you have to start from z squared equals a squared plus b squared. If you always have to start from the Pythagorean Theorem, it's going to take you an extra 30 seconds to solve each of those. So, if you can memorize this, it'll save you 30 seconds for each of those 6 problems. That's 3 minutes. That might make a difference at 2 or 3 points on your test results. So if you can learn to solve right triangles like this, these 2 situations, then you're that much further ahead than the next person. So what's z equal to?
So it's just, alright, so 9 and 16. And then just the square root of those.
What's that sum?
25.
What's the square root of 25?
5.
Solve for x. Give me the equation.
So the square root of 5 squared minus 3 squared. 16.
Square root of 16.
Square root of 16. X equals the square root of 16.
What's the square root of 16?
4.
Okay. So, you know how to solve a right triangle. I'm a little bothered that you don't know your perfect square numbers as well as you should. Okay? Let's just talk about perfect square numbers. What's 1 squared?
2.
No?
1.
Okay. What's 2 squared?
4.
What's 3 squared?
9.
4 squared?
16.
5 squared?
25.
6 squared?
36.
7 squared?
49.
8 squared?
64.
9 squared?
81.
10 squared?
100.
These 10 numbers you want to learn to recognize are perfect square numbers.
Yeah.
So if somebody says, what's the square root of 64, you want to recognize that instantly. That is a perfect square number.
Yeah.
So it's a whole number is the answer. It's not going to be 8.1 or 7.9. It's a whole number. Whenever you take the square root of a perfect square number, it's a whole number. More importantly, if I said, what's the square root of 128, you would recognize that that is the square root of 2 times the square root of 64.
Yeah.
Well, the square root of 64 is a perfect square number, so that's 8 root 2. So knowing these perfect square numbers is really important. You really want to know these 10. After this, not so important. I mean, I know what they are. 11 squared is 121, 12 squared is 144, 13 squared is 169. I don't know what 14 squared is. I think it's 196. 15 squared is 225, and that's as far as I know. Okay? So these 5, you don't need to memorize those. You do want to know those 10 right there.
Okay.
Okay? That's just something in mathematics that you want to know. I try to point it out whenever we come across stuff. Just like I try to tell you that some stuff doesn't matter whether you remember it or not. Proofs are not something you're ever going to be tested on again.
Really?
Not unless you become a PhD in geometry.
Good.
Exactly. It's worth knowing that stuff. What you have to know and what you don't have to know.
Yeah.
This stuff that we're working on now, you have to know. This is all real important stuff, all 3 of these documents.
Okay.
All right. Is 5, 12, 13 a legitimate triangle? The only way you can answer that is to go through each one by itself until you get to all 3 of them. Does 5 pass?
Yeah.
Does 12 pass?
Yes.
Does 13 pass?
Yes.
Okay. And in fact, this is the second lowest Pythagorean triangle. By that I mean a right triangle that has all integers. Okay, the lowest is the 3, 4, 5. That is the lowest triangle, right triangle, where all sides are integer numbers. Okay? You want to memorize that. Because if somebody gives you a problem like this, where they say this is 4 and this is 5, boy, if you recognize that that's a 3, 4, 5 triangle, you don't have to do any math at all. You know that's 3.
Yeah.
Same thing with 5, 12, 13. It's the second lowest.
Okay.
Both of these you want to memorize. These are the 2 lowest perfect Pythagorean triangles. In other words, there's nothing with 6, 7, 8. Okay? That doesn't exist. 3, 4, 5 is the lowest. The next lowest is 5, 12, 13. And the advantage of memorizing both of these is that when you take that ACT test, you'll have at least 6 questions that will reference either a 3, 4, 5 triangle or a 5, 12, 13 triangle.
Okay.
So the ability to recognize it is key. Now, when I say 3, 4, 5, I mean multiples of 3, 4, 5 also. In other words, 30, 40, 50 works.
Okay.
6, 8, 10 is a multiple of 3, 4, 5, right?
Yeah.
Okay. 5, 12, 13. They might give you a triangle that has 10 here, 24 there. Well, what's this side?
26.
Yeah. So being able to recognize those two triangles, and just those two, is huge.
Yeah.
Now let's examine number O. So first of all, they wanted us to know, can this be a triangle, and is it acute, right, or obtuse? Well, I just told you it was right.
Yeah.
So that's a right triangle for sure.
Yeah.
Now let's look at the next one. 5, 7, 8. Let's put it through the test.
Okay, so 5 passes. 7 passes. 8 passes.
Now, I'm not quite sure how to draw this. In other words, I don't know if it's definitely not a right triangle, because I'm familiar with all the low number right triangles, and this isn't one of them.
Yeah.
So it's either obtuse or acute.
I think it's acute.
Definitely is acute. Now, the explanation as to why it's acute, in other words, all three of these angles are less than 90 degrees. The explanation for that really kind of falls into the law of cosines. I gather from the other two papers that I saw that you've studied the law of sines and the law of cosines, right?
Yeah, not as much the law of cosines, but the law of sines, yeah.
Okay. So you're in the middle of that. You're going to get the law of cosines tomorrow, probably.
Yeah.
They come together. So the law of cosines would allow us to tell that that's acute.
Okay.
Let's not talk about it until you get it, though.
All right.
These two triangles are the most important triangles you can learn.
Okay.
Memorize them, never forget them.
Okay.
It's as important as anything else we've talked about here. I'm going to draw them. Now, I have what I call my unit 45, 45, 90 triangle, and the other one is a 30, 60 triangle, 30, 60, 90. Whereas both of them are right triangles. In one case, the two acutes are 45, 45, and the other it's 30 and 60. Now, why these two triangles are so special is hard to explain. Just take my word for it. You want to memorize these, and you want to memorize the relation of their sides to one another. Now, I call them my unit triangles because opposite the smallest angle is always 1.
Okay.
This is square root of 3, and this is 2.
All right.
I just as easily could have said 2 square roots of 3, and 4.
Okay.
But I call them my unit triangles. My unit means that the side opposite the smallest angle is 1. So that helps memorize it.
Yeah.
This one over here, well, if this is 1, that's not only a right triangle, but it's also isosceles, which means this has to be 1. And now if you apply the Pythagorean Theorem, this is what?
2.
No, apply it correctly. Remember, it starts out square root of
Square root of 1 squared
plus 1 squared.
plus 1 squared.
What's that?
2.
Square root of 2.
Square root of 2.
Okay? Notice that over here, on this triangle here, if I tried to figure out what the hypotenuse is, square root
Yeah.
of 1 squared plus square root of 3 squared. Well, that's the square root of 4,
Okay.
which is 2.
Alright.
Okay? But you don't want to have to go to the Pythagorean Theorem on these. You want to have these two things memorized exactly as you see them.
Okay.
And the reason is that they're forever giving you similar triangles. Remember that if I have a similar triangle, got the same 3 angles, well, if this side is 5, what's this side and what's this side?
The other side is 5. And then would that just be square root of 25?
No, it's 5 root 2.
5 root 2.
In other words, the similarity ratio is 5. So
Yeah.
every side is going to be 5 times this one.
Okay.
Okay? This is 5 times that, this is 5 times that, this is 5 times that. So that allows you to completely fill in this section of the table.
Alright.
Okay? So that part is 5 root 2.
Alright.
I hate the fact that they've called that y, because the hypotenuse is almost always called z, and the short vertical side is almost always called y. Okay?
Yeah.
So that completes that part of the table, but if I change it and make, okay, now to complete this column, they're saying the hypotenuse is 4 root 2. Now,
Alright.
what would that make that side and that side?
4 and 4.
Yep. So that goes there, 4.
Okay.
Okay. To do the third column, they said, well, what if this side is square root of 2? What's this side?
Square root of 2.
And what's the hypotenuse?
2.
Good. So 2 goes here.
Yeah.
Now let's do the fourth column.
Okay.
They're telling us that the hypotenuse is 24.
Okay.
It's a little harder. What's the similarity rate? How much bigger is this triangle than this triangle?
2 times bigger?
Take equivalent proportional sides and divide the bigger one by the smaller one.
So 24 divided by square root of 2.
That's the similarity ratio.
Okay.
That's how much every side is bigger on this triangle than it is on this triangle.
Okay.
So what's this side here?
12 root 2?
No. It's 24 over root 2 times 1.
Yeah.
So it's 24 over root 2.
Okay.
In other words, I take my similarity ratio and I multiply it by that side to get this.
Yeah.
I multiply it by this side to get that.
Okay.
Now, there is something wrong with those answers. What is it? What's wrong
I don't know.
What's wrong with 24 divided by root 2 mathematically? Why can I not give that answer?
I don't know.
It's got an irrational denominator.
Okay.
Root 2 is an irrational number.
All right.
Mathematics does not like irrational or imaginary numbers in the denominator. So the way I fix this is I'm going to multiply that fraction by the number 1, which doesn't change the value. Only my number 1 is going to be root 2 over root 2.
Okay.
That gives me in the numerator 24 root 2, and in the denominator, what's root 2 times root 2?
Root 4.
It's 2.
2.
Root x times root x is x.
Okay.
Okay? Now this simplifies to 12 root 2. So it's much better. That is the same number. If you put that into your calculator, you'll get the same number as you get here.
Okay.
The difference is that this number here does not have an irrational denominator.
Yeah.
I've rationalized it. So that's the proper way to write it. And this is the same length because it's an isosceles triangle. So that's the way we solve that problem. Remember that when you deal with similar triangles, you have to find a similarity ratio and then multiply the smaller triangle by that similarity ratio. So let me give you a test before we go to the next one. Let's look at the next one. I got a 30-60 triangle, only this side is 6. What's this side? What's this side?
So are we comparing it to the one above it?
Exactly. That's why these two triangles are so important to memorize. It's not the numbers that are important to memorize, it's the relationships. In other words, this is 1 root 3, 2. It could just as easily be 10, 20, 10 root 3.
Okay. So
what's the similarity ratio?
1 to 3.
No, what are the only two sides that are the same? What are corresponding sides? What is that ratio? 3 to 1. I'm sorry, you did say the answer, didn't you? You said 1 to 3?
Yeah.
I tend to always look at the bigger one first.
Okay.
The reason is that I'd rather deal with whole numbers rather than fractions.
Yeah.
Right?
Yeah.
So the similarity ratio isn't 1/3, it's 3 to 1.
Okay.
If it's 3 to 1, what is this side?
2.
Multiply the similarity ratio by that number right there.
3.
Okay? In other words, the similarity ratio tells you that all corresponding sides have to be on that ratio.
Yeah.
So what's the bottom side?
Is it 3 square root 3 square root 3?
This number is 3 times bigger than that number. How do I know? Well, if I divided 3 square root 3 by square root 3, square root 3's cancel and I got 3.
Yeah.
Okay, so that's the answer. In other words, once I came up with a similarity ratio that was 3, then I multiply that similarity ratio by the other sides to get these sides.
Yeah.
All right. Now, I'm going to give you one more. It's a little harder.
Okay.
Which is the bigger triangle, the smaller one or the top one?
The top one?
What's the square root of 5? Is it bigger than 2 or less than 2?
Less than 2?
Is it? What's the square root of 4?
16.
No, square root of 4 is 2.
Oh, 2.
Right? So square root of 5 has to be a number bigger than 2.
Yeah.
So which is the bigger triangle?
The bottom one?
Okay, what's the similarity ratio going to be?
Is it 2 to 1?
Bigger one divided by the smaller one.
Yeah.
Square root of 5 divided by 2. It's that easy. In other words, don't make it harder than it is. Once you figure out which is the bigger triangle, then just take the bigger side and divide it by the corresponding smaller side, and that is the similarity ratio. Okay? Now we're going to take that similarity ratio to get these two sides. We're going to take that similarity ratio, multiply it by that to get that side, multiply it by that to get the bottom side.
Okay.
So what's the vertical side going to be?
Wait, so what's the similarity ratio?
That is the relationship between the corresponding sides of the bigger triangle versus the smaller triangle. That's where we got square root of 5 divided by 2. This is the hypotenuse of the bigger triangle. This is the hypotenuse of the smaller triangle.
Yeah.
Divide the bigger one by the smaller one and you get the similarity ratio. Okay? What that means is that every side on this triangle is that ratio versus these sides. So what's this going to be?
I have no idea.
Take the similarity ratio and multiply it by that number.
Wouldn't it just be square root of 5 divided by 2?
Correct.
Okay.
Now, what's this number going to be?
Do you multiply it?
Multiply it by what?
The square root of 3?
What's that? What's the square root of 5 times the square root of 3?
Is that
square root of 15?
Square root of 15.
So this becomes square root of 15 divided by 2.
Okay.
In other words, when you multiply, you just multiply numerators, multiply denominators. And when you're multiplying square roots, you multiply the insides. That's why the square root of 2 times the square root of 2 is equal to the square root of 4, which is 2. Okay? So these rules are all very, very basic here. You need to know these rules. Okay? Now, let's look at this other problem, which deals with the 30-60 triangle, which is this one right here. Okay? In other words, completing this table is going to be doing exactly what we've just done for the last 5 minutes.
Alright.
So, if A, let me draw it. This is a different size triangle. But they're saying A is the side opposite the 30-degree angle, right?
Yeah.
So if that's 11, here's the 30-degree angle.
Okay.
What's the similarity ratio?
11 to 1.
Okay, what does that make the hypotenuse?
22.
What does that make this side here?
11 root 3?
You got it. Okay. Now, so that's B and C. We did that column.
Okay.
Now, B, which is the side opposite the 60-degree angle, is 9. The 60-degree angle is right there.
Yeah.
And it's 9. Notice that I don't have mine oriented the same way they do. I did that on purpose. I want you to recognize these as, I want you to see that this 9 is opposite the 60-degree angle.
Okay.
What's the similarity ratio?
Is it 9 to...
Similarity ratio, meaning it's being divided.
To root 3?
Yes. Now, that's the similarity ratio. I don't care if that has an irrational number in the denominator, because I'm not writing anything yet. It's only the final answer that I have to make sure I have a rational denominator.
Okay.
What's this side?
Is it 9 root 3?
9 over root 3. Now rationalize that, because I can't give that as an answer.
Yeah, so...
How do I rationalize it?
3 root 3?
Well, hold on. We're going to multiply it by root 3 over root 3.
Yeah.
Which becomes 9 root 3 in the numerator, 3 in the denominator. That becomes a 3. So 3 root 3 is the answer. Is that what you said?
Yeah.
Good. You were ahead of me. So that's 3 root 3. Now what's this?
Well, it's just times 2, so 6 root 3?
It's the similarity ratio times 2.
Yeah.
No, you got it. Very good. Good for you. You actually skipped ahead of me. In other words, you realize that the hypotenuse is twice that.
Yeah.
So this has to be 6 root 3 after I rationalize it. I was going to do it the slow way, multiply that by 2, which gives me 18 over root 3, multiply by root 3 over root 3 to rationalize. I got 18 root 3 over 3, which is 6 root 3. Okay, so doing it the hard way gives me the right answer, but recognizing the relationship of these sides is far better way to do it, which is what you just did. Okay, so we got our 2 answers for column 2.
Okay.
Now in column 3, C, the hypotenuse is 16.
Yeah.
It's pretty easy. What's this side?
8.
And what's the bottom?
8 root 3.
Okay, you got it now. Finally, the 4th column, B, which is the side opposite the 60-degree angle, is 5 root 3.
All right.
What's this side?
Is it just 5?
Huh? And what's this side?
10.
You got it. All right. Very good, Julian. Remember everything we just did. Forever.
All right. Okay.
That is, this page right here is one of the most important pages in all of geometry. Okay? So if you're ever going to memorize anything, memorize this page or these concepts.
Okay.
All right. Now, we got 10 minutes. Let's look at the second page of that. These are all going to be very similar problems, I suspect. In other words, everything we've learned, you're just going to apply.
Okay.
So, That's 60.
Yeah.
That's a right triangle, so that has to be 30.
Yeah.
So this triangle is our 30-60 triangle that we were looking at.
Yeah.
Next to a square. Find the value of x and y. What's this side right here?
That, I don't know.
That's a square. What's that side?
A square. Okay.
It's a square because it's got three 90-degree angles, which makes the fourth angle 90 degrees also.
Yeah.
And it's got two equal sides, four right angles, so all four sides are 6.
Yeah.
So that's 6 right there. Okay, now let's go back and look at my unit 1. Let me label this as my unit 1. When I say unit, the only thing that matters is that you know the ratio of these things. I could label this as 10, 20, 10 root 3, and it'd be just as useful to you.
Yeah.
So the goal here is to figure out, well, what's the similarity ratio?
Yeah.
In order to come up with x and y, I got to find the similarity ratio.
Okay.
What is it?
So since that side is 6.
It's opposite. The 6 down here is opposite which angle?
The hypotenuse?
Which angle?
Oh, 60?
Okay. So you're looking for the side up here that's opposite the 60.
Yeah.
Which is root 3.
Yeah.
So what's the similarity ratio?
6 over root 3.
Okay, good. Now we're going to multiply to get our other sides.
Yeah.
So what is the side opposite the 30-degree angle?
Just 6?
Remember, we multiply it by 1. We multiply it by that side.
Oh, yeah. 6 root 3.
Okay, rationalize that.
3 root 3.
Hold on. You rationalize it by multiplying it by 1.
Okay.
Whatever this is, it's this over that. That is 1. It's going to work because it changes the denominator into a whole number. What's the new numerator?
3.
What's 6 times root 3? That's what it is.
6 root 3?
That's what 6 root 3 means. It's 6 times root 3.
Okay.
What's root 3 times root 3?
3 root 3?
No, just 3.
Just 3?
Remember that root x times root x is x.
Yeah.
Root 3 times root 3 is root 9, which is 3.
Yeah.
Now simplify that.
So, is it 2 root 3?
So that's what y is.
Okay.
It's 2 root 3. Now, what is x?
X is 4 root 3.
Okay, good. You did it the quick way again. And that completes number 7.
Yeah.
Okay, let's look at number 8. We'll finish with 8 here.
Alright.
Notice that we have a 30, 60, 90 triangle right here.
Yeah.
Okay, so let's solve for x.
Okay,
Now let me draw my basic one. I want you to memorize this at some point so I don't have to keep drawing it.
alright.
Once you memorize it, in other words, unless you have it memorized, it's hard to figure out the similarity ratios. So in this triangle right here, what is the similarity ratio?
The similarity ratio is
Compare equivalent sides.
alright, so 16 to 2.
16 divided by 2.
8 to 1.
Uh-huh.
8 over 1, yeah.
Okay. So what's this side x, the side opposite the 60-degree angle, going to be?
Would it be 8 root 3?
Uh-huh. And what's this side here opposite the 30-degree angle?
Just 8.
Correct. So now let's look at this triangle over here.
Yeah.
Which is also a right triangle.
Okay.
Because if that's a right angle, that's a right angle. We know that that was 60, right?
Yeah.
And they tell us the entire angle is 105. So what's this angle right here?
So 75?
What's 105 minus 60?
105 minus 60. 45?
Ah, that's our 45-45 right triangle. That's our other special triangle.
Okay.
And what do we know about this? We know that the side opposite the 30-degree angle was 8.
8.
Okay.
Yeah.
So now the triangle we want to reference is our 45-45 right triangle, which is 1 root 2. So we don't care about this triangle anymore. We do care the similarity. No, we don't even care about that. We got a new similarity ratio. What is the similarity ratio of this triangle versus this triangle?
Isn't it just 8 to 1?
Still 8 to 1.
Yeah.
Okay. I don't know if that was accidental or not, but probably not. Okay. So, what is z?
Z would be 8 square root 2?
You got it. And what is y?
Isn't it just 8?
I think you understand it.
Yeah, I think I get it too.
I think you get it. And that's a big thing to get, let me tell you.
Yeah.
You just up your score on the ACT test by 10 percentage points.
That's good.
Serious. You did. As long as you can remember this.
Yeah.
Okay? And you just are not going to believe how many 30, 60, 90 or 45, 45, 90 triangles you're going to be presented with.
Okay.
All right? Julian, I got to run. I got a 7:30 I kind of forgot about here.
Okay.
I will talk to you next time. Have a good week.
All right. Thank you.
Bye-bye.